continuing here with identities, doing some more more advanced problems, more complicated problems with a few more steps. So here we want to establish this identity or verify this identity. Show that this side is equal to this side. We're starting on the left here. Looks a lot more complicated. Don't be tempted to do this. You might see 1 minus cosine squared and think, oh, Pythagorean identity. But no, cosine squared here is in a fraction, 1 is not. But one of our strategies, we want to combine these into one fraction. So you need to multiply 1 here times 1 plus sine theta over 1 plus sine theta. So you get 1 plus sine theta. Now both fractions in the same denominator, so you can write it as one fraction. So it's over here 1 plus sine theta minus cosine squared theta over 1 plus sine theta. That's my common denominator now. Okay. 1 minus cosine squared. That's sine squared. Sine squared theta. Oops, there. Plus sine theta over 1 plus sine of theta. Okay. See, I mentioned I want to get to sine theta. Here, I have sine squared plus sine. I can factor out a sine. So sine theta times sine theta plus 1 over 1 plus sine theta. One plus sine theta cancels with 1 sine theta plus 1. They're the same. Cancel, cancel. Sine theta equals and sine theta. This next one here, actually look at both sides. Well, this doesn't really look like either one's more complicated. They both look kind of complicated. You might see, oh, cotangent. Cotangent seems to be more complicated than tangent would start on the right side, which will be fine. You eventually get there. However, I can see that both sides look really kind of similar. Kind of like the same pattern here with like adding 1, subtracting 1. I feel more comfortable with tangent, so I'm going to start on the left side here. Let's see. Tangent is sine over cosine. That's usually a good idea to change anything to sine and cosine. So let's go 1 plus, actually, you know what? Let's not do sine cosine. Because think, we want to get over here. We want to make it look like cotangent plus 1 over cotangent minus 1. So yeah, we could go sine and cosine, but then we're going to probably have to switch it back to cotangent when we're done, because we know we want to get here. Let's just rewrite this side so it uses cotangent instead of tangent. So 1 plus 1 over cotangent theta over 1 minus 1 over cotangent theta. Okay. I think it's a better strategy here, because if we could change anything to sine and cosine, at the end, we're also going to need to get back to cotangent, so we'll just rewrite this side with cotangent. Both numerator and denominator here, I have separate terms. I want to write these as one fraction. So 1 here, you multiply by cotangent over cotangent. So cotangent theta over cotangent theta plus 1 over cotangent theta. All over, same thing here, cotangent theta over cotangent theta minus 1 over cotangent theta. Okay? Same denominator, add fractions, same denominator, add fractions. Cotangent theta minus or plus 1 over cotangent theta, all over cotangent theta minus 1 over cotangent theta. We have this double fraction here, a fraction and a fraction divided by. So I'm taking my first fraction, this is my numerator, take my numerator and divide it by this fraction. When we divide fractions, we keep the numerator, multiply by the reciprocal of the denominator. Cotangent theta minus 1 over cotangent, plus 1, cotangent theta plus 1 over cotangent theta. Times, multiply by the reciprocal of this one, times cotangent theta over cotangent theta minus 1. cancel, cancel. Cotangent theta plus 1 over cotangent theta minus 1, and that is what we wanted. Very good. Okay, our next one here. This one doesn't really look too complicated, but it has a little different solution method here, so that we should go over. We have tangent theta plus cotangent theta equals secant theta times cosecant theta. So right now I want to make a decision which side I want to start with. Let's see, over here on the right, we were multiplying. I remember in class the other day, I was like, ooh, I kind of want to start with one where we multiply because we might have something, oh, cancel. I like canceling. I look at this here, I see, well, it's going to be 1 over cosine. It's going to be 1 over sine. So nothing's going to cancel. I'm going to have 1 over sine times cosine. You get 1 over sine times cosine. And I'm not really sure where to go from that. So I can kind of see a couple steps ahead here. I don't know if I want to start over there. Now, eventually you could get the right answer, but I see over here, I'm going to have two separate fractions, and when I combine them, some good stuff might happen. So, tangent, that's sine over cosine, plus cosine over sine, cotangent. Okay? I'm going to add these fractions, but we need a common denominator. I have cosine here, I have sine here. So this first fraction got multiplied by sine over sine. Get sine squared theta over sine theta times cosine theta. Plus, I need a cosine here, so times cosine over cosine. Get cosine squared theta over sine theta cosine theta. Ooh, I like this. I like this. Sine squared plus cosine squared, they're the same denominator. I can add the fractions. I like this. Sine squared plus cosine squared is 1 over sine theta times cosine theta. Hey, that sounds familiar. I need secant, cosecant. I have 1 over sine, 1 over cosine. They go to the numerator, reciprocal, up to the numerator becomes, let's write it in the right order, secant theta, cosecant theta. And we are done.